Good morning, everybody. Welcome, big warm welcome from OpsMx. Thank you very much for joining us for today's webinar. My name is Ashley Owen. I am head of product marketing here at OpsMx. I'm relatively new, but I can tell you what, I'm very, very excited to be here because here at OpsMx, our vision is to enable all enterprises to deliver software without human intervention, which I think is tremendous. Today, we are presenting 3 easy steps to implement GitOps. To implement GitOps or AWS EMC using Spinnaker SaaS. So just before we get started, a little housekeeping. If you have any questions during the presentation, I encourage you to type them into the chat box. That's going to be essential, and we'll be happy to address them at the end. So let me begin. I just want to, where's my poll button? I had a poll to run, but I can't see my poll. Oh, that's interesting. I was going to run a poll. All right. Well, without further ado, let me introduce our speaker. Bob Boulay is Head of Solutions Engineering here at OpsMx, and he is a dynamic technology enthusiast and leader. Over to you, Bob.
Great, thanks so much, and thank you for that that very generous introduction. I really do appreciate it. So, guys, I think what I want to do today is a 2-part presentation, right? So those of you that have come to my presentations in the past know I've got some PowerPoints that we'll run, and then we'll look at some real world scenarios, and so that's the sort of lay of the land there. And I guess again, as Ashley had mentioned, the theme for today is around sort of using GitOps along with ECR to ultimately an ECS to ultimately be able to deploy containerized workloads on the AWS platform in a GitOps fashion, right? So obviously a lot of you that are out there that we've had conversations with in the past, or folks that haven't talked to us yet, we understand the need, right, to sort of make sure that from a GitOps perspective, the right pieces are supported in the right places. I think that regardless of the sort of tooling that we bring in as DevOps professionals, ultimately our engineering and our developers are our customers, and we want to make sure that they are able to work in a way that is most familiar to them, that is most conducive to sort of what they're comfortable with. And that's really where I think we started thinking about, and I think the industry in general started to sort of shift toward more of a GitOps model, right? To be able to make sure that we fit into sort of those workflows that are already native to the software developer. Now today, we're going to be talking about sort of the journey around sort of containerized services and sort of where you might be on your journey, and then how to go about using or leveraging that combination of the OpsMx Intelligent Cloud, which is essentially one part of it being SaaS Spinnaker, along with a GitOps-style model to ultimately be able to deploy workloads into the container service hosted by AWS. And so that's really what we're going to focus on today. And again, I think we'll also at the back half of the presentation talk a little bit about sort of what are the keys to deployment, right? So what are the things that are important? For those of you that have heard me in the past, I've got my sort of 3-legged stool piece where I talk about, sort of managing velocity, managing risk, and managing quality. So we'll talk a little bit about that and then go ahead and dive into some Spinnaker pipelines, which I think is always the most fun part of the presentation. So, when we talk about containerized services and I think, by the way, I want to apologize to anyone if you hear some sniffles. I did wake up this morning with a bit of a cold, so I do apologize for that. If my voice is a little raspy, I'll sort of keep that to a minimum. But anyway, so when we talk about containerized services, sort of where organizations are in terms of what the industry has dubbed that digital transformation. It starts, sort of at the bottom left there with monoliths. That was the way to go about deploying applications. You either had bare metal, or you had VMs that were deployed through some sort of virtualization technology that ultimately, and then you wrote some orchestration, right, to ultimately go ahead and deploy, right? So you used tools like Ansible or Puppet or other things to go ahead and write, or you manually wrote your own sort of orchestration layer to ultimately take software once it's completed the sort of development cycle and then deployed to that monolithic style scenario. And so, ultimately, this was, sort of full stack, everything included, sort of here it is, let's push it out there, and let's, replace what's currently there. And so, you start talking about things like maintenance windows and how much downtime and things of that nature. And then the industry began to evolve, right? I mean, Docker and the Docker revolution and started the process of containerizing workloads and looking at ways to go about orchestrating those containers, right? And so whether you were a user of sort of Docker or Docker Enterprise, sort of on premise, or sort of as the cloud providers started to sort of roll out these types of services like AWS, where you could ultimately run these containerized applications. That's really where we started to get into and started to see sort of the GitOps-style model, right? Because you had some of the early sort of types of orchestration layers like Swarm and other sort of orchestration layers that Docker had sort of came out with to ultimately go ahead and push these things out, along with AWS and their container service and their container registry service. And so, some of us, quite frankly, are still here, right? Some of us are, as a matter of fact, a lot of us are still here in that, you don't sort of move from left to right and sort of up that chain quickly, right? I think, going from monoliths to sort of more containerized workloads was something that it had to be done very carefully, but I think was mildly easier because it didn't absolutely require, sort of a full re-architecting of your application. But as we move from, sort of those containerized workloads up to sort of the microservices type of architectures, this is really where you start to get into sort of high investment, high risk, and you have to really sort of understand whether or not the application itself, is suitable to this. Right now, a lot are, and a lot of people will find a way if they want to get there. But I think a lot of us are saying, hey, look, let's pick off the low-hanging fruit. Let's maybe start to design, sort of net new applications so that they fit into this microservices model, which can then be orchestrated through Kubernetes or Nomad or other technologies, right? But I think, there's a lot of workloads there that are still sort of in the containerized elements, and it's not necessarily a bad thing at all. I think, one of the things we have to recognize, and I think a lot of us did over time, was when we made that shift from bare metal to virtualization, and then from virtualization to containerization. I think there's a lot of laggards there, right? And there's probably still some legacy applications that are out there that are sitting on bare metal, right? And so I think what we want to talk about today is sort of that middle circle and sort of how Spinnaker as a transformational technology, right? And I think that one of the things I like to talk about is how Spinnaker really sort of helps you. It doesn't chase you up to the far right? It allows you to go ahead and ultimately say, hey, I'm still deploying monoliths, and so I want to deploy EC2 instances. I've got some, sort of containerized, but not, sort of architected for microservices yet type of applications. And hey, I want to continue to deploy that way. And then I've got my microservices application. So Spinnaker really can span the entire spectrum here, and I think that's one of the reasons why it's such a popular tool as it relates to CD. And so we'll talk a little bit more about sort of how Spinnaker can help you in this particular area right here. So when we think about leveraging sort of the container registry and container service with OpsMx Intelligent Cloud, really this is sort of at a high level what this looks like. And so let me walk you through, at the top that should say ECS. That's just a typo on my part. But let me walk you through sort of what that looks like. And by the way, we're gonna look at an actual pipeline here, and a couple of actual pipelines here as the presentation moves forward. But I think when we think about Spinnaker as an orchestration layer that's sitting in between these and enabling sort of that GitOps model, one might look at this and say, hey, sort of how does that work? We start at the top with Git, right? And so within Git, I might have my Docker file, right? So my Docker file is there. It's going to have all the attributes and all the things that I need in order to actually build my image. And so this makes it very, very straightforward from that perspective, in that, you know, the developer can sit here and manipulate this and ultimately understand sort of what's going to be in that image, what that image is going to look like, how that image is going to be configured, you know, from an OS perspective. So I can ultimately manipulate that from here. And this is where it all starts, guys, right? So, you know, I can look at this and say, I want to monitor this Git repository that has this Docker file. And then from there, once changes are made to that, let's say I you know, submit a pull request based on some changes that I've made to this Docker file, and then that gets merged to master, that can then trigger the Spinnaker pipeline. You know, so from there, you know, Spinnaker gets triggered to kick off the pipeline. The next step in the process is to actually build the Docker image, right? So your CI system, whether it be things like AWS Code Build or Jenkins or some other sort of CI tool, where you're going to ultimately, you know, build that Docker image and then ultimately push that Docker image to some form of repository. In this case, it'd probably be something like ECR, right? Where I'm going to go ahead and push that up to the container registry and make it available to ultimately go ahead and actually push that out. And so, and then once that's pushed up to ECR, then I can ultimately go down the path of using Spinnaker to deploy that that new image, right? And again, I think deploying that new image, it's not just about, you know, sort of spinning up the new one, right? It's about, you know, sort of what is my deployment strategy going to look like, right? There's a pretty good chance that I've got a load balancer that's in front of this application stack. And so as I replace these containers or deploy these new containers, I want to make sure that, you know, I'm doing it safely. And so there's a lot of different types of deployment strategies, like a blue-green, or what Spinnaker calls a red-black, or if I want to deploy canary, depending on the type of, you know, if this is more of a stateless type of container, I can deploy a canary and sort of monitor, you know, sort of its health as I start to steer some of my traffic toward it. So there's a lot of different techniques that you can use to ultimately deploy this. But again, I think using the GitOps model, being able to go from a change in code, which is the Docker file, to trigger a build using Jenkins, and then to ultimately pushing to Amazon ECR, and then ultimately using Spinnaker to then take that new Docker image and deploy it as part of my application stack. And so that's the crux of what we're talking about here, is sort of how that would work. And again, you know, from the developer perspective, all they have to worry about is they've made the necessary changes to the Docker file. They've made the changes to the code that's behind this, and then submitted that pull request. And from there, everything will just happen, right? They don't need to worry about going down the path of, hey, let me go and wait for this build to happen, and then let me go and then, you know, write some other script that needs to go and push this thing to ECR, and then ultimately take it from ECR and deploy it. They don't have to worry about all that stuff. There, it stops and ends with them making that change, and then the automation will handle the rest of it. And they'll also get that communication as it goes through each step in the process. And so really that's where an orchestrator like Spinnaker comes in. And, you know, specifically, you know, something like, you know, OpsMx Intelligent Cloud with Spinnaker under the covers is really going to come in to ultimately allow you to get that level of orchestration and go from, you know, sort of the fingertips of your developer all the way out to a deployed application. Now, you know, there's a lot of tooling that's out there, and I think, you know, when we start talking about the ways to go about deploying containerized applications, right? I mean, obviously, again, if you're in a microservices scenario, that's covered. If you're still in monolithic type of scenarios, again, with Spinnaker, you've got that covered with the build and bake pieces. But here, you know, we're able to, you know, sort of interact with a lot of the services that are out there that are enabling this. And two in particular, you know, something like ECS or Cloud Run, right, where you can take those containerized applications and you can, you know, orchestrate the new build and then ultimately push that new build out there. And when we get into, you know, sort of starting to talk a little bit about sort of Spinnaker, and we get into some examples of some pipelines, we'll start talking about sort of how we can do that safely. And again, you know, I think that the idea behind this is, you know, we're running this sort of GitOps model. We're focused on the developer. we want to make sure that as they move through their process, the rest of the orchestration moves around them, and ultimately we can then go down that path of sort of deploying again with complete automation, right? With complete automation, with guardrails, which we're going to talk about here in a little bit as well. I want to make sure that I put some guardrails up because I do have to manage or sort of make sure that I'm looking at those three pillars, that being velocity, risk, and quality, right? So we want to make sure that that's there. But again, at the same time, we want to make sure this is as simple as it can be for the developer to initiate that, because really the developer is worried about their code. They want their code as they're pushing it out. They want it deployed to production in as fast a fashion as possible. So again, if we were to recap sort of the flow here, right? Again, I'm a developer. I've decided that we want to make some changes to this application. I've gone ahead and updated the Docker file so to reflect some of the new code changes. I want to now generate that image. All I've got to do is hit that commit button, to commit that to the appropriate branch, and then ultimately the Spinnaker integration will take over from there, and ultimately go ahead and actually kick off that pipeline. That pipeline could be orchestrating through the various CI tools and build servers. That orchestration tool ultimately go ahead and actually pick up the artifact that's necessary and deploy it to one of the services that we're talking about. So again, as we look at that flow from left to right via automation, we're looking at developer, Git, Spinnaker, production, right? And ultimately getting all of those things, sort of working in concert. And again, making it simple because we've put up some downstream guardrails as well. So the developer doesn't have to worry about, if there was a mistake made or a typo or something happened. We've got, sort of downstream guardrails in the form of policy checks, in the form of continuous verification, the form of automated approval steps or human assisted approval steps that will allow us to go ahead and make sure that there's an entire network of those checks and balances that are happening. But from a developer perspective, all they have to worry about is, hey, I've committed my code and now I know it's on its way to production. And so that's the flow that we're aiming at. And again, when we think about sort of deploying to containers, again, it's that simple, right? It's that simple with Spinnaker, as we'll see as part of the demo portion. So let's take a closer look at the orchestration. And I think one of the things that I talk about in my presentations all the time is when we start to think about orchestration and we start to think about sort of how deployments happen, right? From a DevOps professional's point of view, because of course we want to make this simple for the developer, but we also want to make sure that we're working within the parameters that are set forward by our organization. We want to make sure that we're able to meet those velocity goals, right? So how quickly do I need to deliver code? But I also need to make sure that I'm managing risk, right? Whether that be compliance risk, security risk, or policy risk, right? And can I do that in an automated fashion? Do I have to sacrifice velocity to be able to sort of manage those risks? And I think, here at OpsMx, our answer is no, you do not, right? Because we want to take you from a paradigm of let's stop the pipeline and look for a problem to let's build automation that will detect a problem and only stop the pipeline when we detect one. And then there's quality, right? So you don't want your users exposed to badness. And here, the lever we have to pull on obviously is not just, sort of QA and sort of regression testing and unit testing, but also continuous verification. So we start getting into, some of those safe deployment options where we start looking at, hey, can I do a canary? Can I do a, sort of a blue-green? Should I be doing a progressive rollout where each step along the way, I'm assessing any anomalies that I might be seeing as part of the log and metric analysis based on the new code being rolled out. And so, I think, the thing that I always like to talk to people about is, I think most of us, in our career have figured out how to manage two of the three. But when you add that third one there, things start to break if you don't have the appropriate automation in place. And we want to make sure we're empowering our customers and to deliver all three of these. And so that's really where OpsMx is really sort of delivering. And, again, for those of you that have seen my presentations before, you've seen this. This is an older Gartner study, but I still think it holds water, right? Because I think the basic principle here for a lot of us is, look, as I start to pour gasoline onto the fire, as I start to look to deliver faster, that's where and apply pressure to my process, that's where I start to uncover problems. And I think, most of us, when we look at this, I think, would agree that, when my business is at a place where I can sort of manage this on the back of a napkin, all is good. And that's where I start to do things like, hey, I don't need heavyweight orchestration. I can write some glue code and ultimately go ahead and make sure my deployments happen from my CI system. But as you start to apply pressure to those things, you start to see the cracks. And as your business grows, that's where you start to have to apply pressure. And that's where some of the risk factors start to come into play, right? So it's easy enough to say, hey, I'm only managing 2 or 3 different applications. And so if something is detected that's wrong in one of them, I can just roll it back. I can do it manually. But when you start to try and manage, 100 or 1,500 different microservices, and you need to be able to make sure that each one of these things passes or is compliant, this becomes a real problem. And this is really where this particular piece here, as that velocity starts to increase, we start to see things that start to break. Now, the friction points here are pretty straightforward. I think this is going to be a graphic that we can all relate to, right? And this is whether you're deploying to containerized sort of technologies, or if you're deploying microservices, or if you're deploying monoliths, this sort of level of friction point sort of applies to all, right? So the first off is sort of that automation issue, right? So can I create repeatable deterministic workflows, right? So how do I create those workflows and then ultimately tie them to things sort of left of center? So how do I tie them to Git, and how do I tie them to Artifactory or Jenkins? How do I tie those things together depending on what my model is, right? So how do I trigger and then sort of tie those things all together in sort of one sort of workflow, or a series of workflows that might be nested? And then the second part of this is around command and control. So how do I make sure that, one, as my business grows, I may want to start to adopt some best practices, whether it be separation of duties, or I start to develop my DevSecOps practices, where I've invested in a bunch of tools, but I want to make sure that these tools are being utilized and that they have a seat at the table. So as an example, one of the steps that might happen here is I need to go ahead and take that container, or that image that has been generated or built by that new Docker file, and I need to go ahead and run a security scan on it. So I need to, either run a black duck scan or a twist lock scan or some other type of security scan on it. And I want to make sure that if there are any vulnerabilities or any high vulnerabilities that are detected, or whatever the threshold is that I've set in my business, I want to make sure that this pipeline doesn't go forward, right? I can't expect my developer to have vetted that from a security perspective. So I want to make sure that's there. Application risk and verification, along with some diagnostics, again, as I apply pressure to my code. So depending on the type of application I'm deploying, maybe I want to either monitor for anomalies during the testing process, or maybe I want to deploy in a canary fashion, and then ultimately, as I start to steer more traffic, I want to look for anomalies there. And so again, in that container mode, again, I'm deploying that container and maybe steering just a portion of the traffic there over the course of a 15 or 20-minute period, and then running an analysis that says, were there any log or metric anomalies that I didn't see prior to sort of pushing this into production? And then there's the policy and security checks. I mean, look, at the end of the day, the organization is going to have a set of policies, and I would think that most developers are aware of those policies and attempt to code within those policies. But again, when a deployment, it's always a story that I like to repeat here when it comes to policy checks are, do I have guardrails up to make sure that a given container or a given application is deployed in a certain VPC or in a certain region only, right? I don't want to accidentally, sort of deploy it someplace where it shouldn't. Well, I think we can put some automated guardrails up around that and make sure that doesn't happen. We talked earlier about things like security checks and being able to either do an automated or a human assisted check around those scenarios. And so really, when we start thinking about these things, we start thinking about where those friction points live, we want to make sure that we're providing a level of automation as you go through and do those deployments. So when we look at, again, sort of stabilizing the three-legged stool, as it were, we're talking about automation, right? So we want to make sure that we have, or we're able to maintain a level of velocity, right? So as those changes come down, the beauty of, sort of the containerized, sort of application deployment strategy is that those things can happen fast. They can happen very quickly. And so as long as I've got the tool chain there to be able to sort of make sure that that's happening at velocity, I then need to make sure that I'm stabilizing my risk evaluation, right? So, do I have those tools in place to make sure that, I'm not incurring unnecessary compliance risk? If I'm a publicly traded company, I need to make sure that I can prove out for my auditors that there's not a direct line from, sort of a single potential bad actor or an engineer right to production. I need to make sure I have a step in there that separates those duties out. And so let's make sure that I have that. Let's make sure that I've automated, sort of some of the decisions to remove some of the human interpretation, but let's make sure I've got that sort of our human assisted gate there. And then obviously when we start talking about quality, look, I don't want to stop my pipeline and grep logs looking for anomalies, or look for specific error codes, because specific error codes implies that I'm looking for things that I've already seen. I need to be able to anticipate and look around corners, and that's really where sort of continuous verification, that's going to allow you to go ahead and actually spot anomalies in the code, or in the run as you're pressure testing the code, I should say. That's really where OpsMx is looking to bring that level of analysis. And again, all of this, everything that I've just said over the course of the last two slides, is great, and it's what you should be doing. But again, we have to remember that if you're doing these two things here, if we're really sort of diligent about our risk management and our quality. Oops, let me go back. Wow, this got away from me. There we go. Risk management and quality. What does that do to our velocity? Or if we come along and say, hey, look, velocity is all that matters, what does that do to risk and quality? Without automation, these things, it's really hard to bring all these things together. And I think that's one of the things that we're talking about here. And so when we talk about the GitOps model, when we talk about, sort of getting code from the fingertips of your developers through a process and out to production where it can start adding value to your users, those are all velocity plays, right? We want to make it easy. We want to make it simple. We want to make it fast. However, we want to make sure that we're not ignoring these other pieces. And so that's really where OpsMx is gonna come in and ultimately offer a solution. And so just real quick on the OpsMx, sort of how we solve this problem, and then we'll get into some practical real world examples. So when I look at OpsMx, and sort of what we're doing, especially our intelligent cloud. So, when we look at that sort of fully automated software delivery process, it starts with an underpinning of Spinnaker, right, for a lot of our customers. Now, we can offer some of our automated decision making and sort of automated logging and audit pieces to our Jenkins and Tecton and Argo customers as well. But if we were to look at the intelligent cloud, we're going to go ahead and give you those underpinnings of Spinnaker. And the nice part about that is that we're going to allow you to use that sort of really world-class orchestration layer without having to worry about the setup, configuration, and orchestration, or I should say maintenance of that tool, right? So it becomes a very turnkey scenario for you as the user to say, hey, I need an intelligent cloud instance. I get the goodness of Spinnaker without having to worry about processing updates or upgrades or looking for problems in the system. That is left to us, from the OpsMx side. And then the second piece that you get there is that autopilot stack, right? Where we help you manage the risk and quality, right? So Spinnaker is our velocity play. And then, we're looking at our velocity portion of the stack. And then autopilot becomes that command and control layer that gives you visibility and insights, governance along with policy, compliance, and audit, verification and approvals, and then ultimately creating a system of record there so that what state a particular release was in when it was approved. What was the status of the Jira tickets? What was the status of the SonarQube scan results? What was the continuous verification score? What was the confidence score that was there? And so you're getting all those things with OpsMx. As you go and deploy these containers, you're going to get that level of detail. You're going to get all that information. So it's not just let's push this thing out there as fast as we can. Let's do that, but let's also be very measured in the way we do that and ultimately make sure we're incorporating those pieces that are very important. Okay, so let me abandon the PowerPoint part of this for now, and let me start talking about or start showing you, some of the sample pipelines, right? That I like to show off. I'm going to start with, sort of this particular piece here where it's a basic pipeline, but I think it's really important from the subject matter that we're talking about today in terms of releasing to ECS and ultimately being able to do that with a sort of a GitOps model. So when I look at this, I look at sort of the pipeline configuration itself. All pipelines in Spinnaker are going to start with a triggering event. Now, in this case here, one of my colleagues just put this on a cron so that we can go get that daily. However, in a GitOps model, I would simply come in here and ultimately add a Git repository that I wanted to monitor. Now, this is going to allow me, for this particular application pipeline, to choose the Git repository that I want to monitor, the branch that I want to monitor of that Git repository, right? So maybe I don't want to release every time something gets pushed to, sort of a staging branch or something. Maybe I want to wait until those things are merged to master. So I can specify the branch and ultimately make sure that I'm monitoring that Git repo. What we're doing behind the scenes, by the way, guys, is we'll receive a webhook from that particular Git repo that will ultimately trigger the pipeline here, right? So that's, one of the pieces here that's really nice is, again, I'm working through that GitOps model. I'm waiting for those changes to Git to ultimately be pushed up. And then I'm going to go ahead and trigger my pipeline. Now, the next step in that process is, I want to go ahead and actually use, let's say, my Jenkins server, right? So I want to use Jenkins to ultimately go ahead and actually run the build, right? So I go ahead and select the Jenkins job. I can ultimately go through that process of doing that, and it will go ahead and, based on the pipeline being triggered, this is the job that I can select that would ultimately go ahead and actually build my Docker image, right? Now I can do the same thing here with CodeShip, right? So if I were to want to do that, or code build, I should say, I can do that with code build as well. So I can go ahead and trigger the system that's ultimately going to say, hey, go grab the Docker file and then build the image and then push the image someplace where I can go grab it. Now, the next part of the pipeline here would be to go and actually find the image based on a tag, right? So here I have the ability to go ahead and actually define a tag for that particular image. Now, assuming that I've connected up to my AWS account and I'm using ECR, this is going to go look in ECR for this image tag, right? Now, I can also, if it's not latest, one of the things that I can do here is I can actually pass in a version from Git, right? So I can pass that version in from Git and grab that variable. I can define that variable back during my configuration stage, where I can come down here and ultimately define those variables or parameters, right? And ultimately use the spell expression language to ultimately evaluate the variables and ultimately grab that version of the image that I want to grab based on this this particular piece. And so I don't have to hard code that at all. I can certainly pass that in. That's really, really straightforward. And then ultimately, once I've got that, I can then go ahead and ultimately deploy. And again, because we are very integrated into sort of what's happening with the various cloud providers, this deployment becomes very, very straightforward, right? I simply can, pick a strategy here. I can ultimately go ahead and actually manipulate the server groups as I see fit. I can, make sure I'm picking the region, the container image I can define here as well. And then ultimately, go through that whole process of, defining what that deployment is going to look like on ECS from Amazon. So that's really sort of, it's that simple, guys, in terms of being able to do that. These pipelines do not need to be extremely complicated. Now, they can get that way, if you have other concerns. as an example, one of the things you might choose to do is you might choose to do that deployment and ultimately, make that deployment a more of a progressive delivery, right? So let's say I'm going to deploy a containerized application. It's sitting out in front of a load balancer. One of the things I can do here is deploy in sort of a blue-green fashion, deploy my green, and then ultimately use whatever traffic shaping technology that I want to, whether it's Istio or it's App Mesh from AWS, or if I'm in the Kubernetes world, I could be using an ingress controller and manipulating that. But again, I can go ahead and actually split the traffic, and ultimately for each step along the way, let's start with 30%, and then let's go do a validation. Now, that validation is, what I've done in the background prior to running this pipeline is I've went through the process of creating filter templates for my log and metric collection items, and ultimately are looking at this particular application or this containerized application and the things that ultimately are being deployed there, so that I can start to gather up those log and metric pieces. Now, as I do my validation, again, it's very, very straightforward from the perspective of, and let me get to the spot where I can ultimately show you that particular piece here. I don't know where that went. Disappeared on me. So let's go ahead and add. Perfect. And what we can see here is, the ability to go ahead and actually look at the logs and metrics. So as I roll that new containerized application out, I'm tied into the logs and metrics through my OpsMx tooling. And ultimately, I'm just looking at those log clusters that look anomalous. Now, what we're doing here, guys, is we're creating baselines for these applications, right? So as I go through and create these baselines, I can analyze the logs and look for what was unexpected, and then further classify that based on whether it's a warning, an error, or a critical error. Now, again, I think one of the pieces here that is key is that ability to go ahead and actually have this algorithm also learn, right? So as I do this analysis, I may stop my pipeline because I just simply saw too much in the way of unexpected log traffic or log clusters. I could do the same thing here, by the way, with metrics as well. I might say, look, if I've got a metric that falls too far outside the baseline, let's stop this, right? And stopping it might include rolling it back, so I could automate that process as well. But I think here, once I've stopped the deployment, let's say I've stopped the deployment and I've decided to roll back, but now I need to figure out where I went wrong. I could get my SRE team, I could get my DevOps team to come in, and ultimately, if they see things that are just simply not relevant, or look, as an example, this SQL unable to establish a connection, this might be a database warm-up issue, right? So I might choose to ignore, not just blacklist this error message, but ultimately choose to ignore this error cluster in the context of this application, and even in the context of where it is from the start time, right? So that I know that I've got this sort of database warm-up issue, and it sort of resolves itself. It's sort of a race condition. The other thing that I can do here is, if I do find a legitimate problem that's associated with one of these log clusters, I can actually tag that, right? So I can come in here and put in some notes, and I can create a tag that will identify what the problem was. And so here, again, if you picture this in the context of deploying a containerized app, again, you're finding these things, you're classifying them, you're figuring out whether or not they're important enough to stop a build, and then ultimately going through and fixing any issues that you find in order to go ahead and ultimately sort of redeploy this application. And so again, this is really where that quality piece comes in. This level of analysis is completely automated by the OpsMx Autopilot stack. Now, again, when we start thinking about these pipelines, we're really sort of thinking about, again, making sure that for each step along the way, I have, a ripcord that I could pull, right? So if traffic validation fails for whatever reason, if a human comes in and looks at it and says, nah, we can't move this forward, I got to have a rollback step. And so this idea of, being able to have conditional expressions within your orchestration tool, sort of if this then that type of scenario, right? So if this particular stage fails, let's initiate a rollback. If it succeeds, let's move on to traffic shaping 50% of my traffic now, right? So now I'm putting the application under some additional load, and then ultimately rerunning the validation analysis there, and ultimately keep going down the pipe until I get all the way to a point where I want to make a decision. Do I roll back here, or do I scale down my original application? So do I start to tear down those containers? So this is sort of really where we get into that piece of validation and validating and those different deployment strategies that allow you to manage quality from the customer perspective. Now, a couple of other items that I want to mention here that I think are particularly relevant, especially in the context of sort of containerized application deployments, are things like our sort of human assisted gates and our automated gates. So here, one of the things that we're doing is we're gathering up all of the information that we know about this deployment. So, whether it be Git repository information, right, and the code commits, the Jenkins jobs, the SonarQube results. I could have Jira or ServiceNow ticket status. I could have Twistlock or other sort of scanning technologies here. But all that information is gathered here, and it's done for two specific reasons. One, to create a human-assisted decision gate, right, that I need someone to come in and approve. And I can ultimately go ahead and push out a Slack message or an email or some other sort of form of communication. The other thing that I can do here is make sure that I limit the approvers to certain groups within my organization. This is where I get that separation of duties, where I can make sure that people other than those in the developer group are going to be approving this. The other thing that I'm doing here is I'm actually creating a system of record. So the status of all these data points at the time of this promotion to either QA or staging or to production is there's a snapshot of that information here, so that if I have to do a postmortem or if I have to, do an audit, I can certainly do that and know what was where when this was approved. Now, the other part of this comes in around sort of policy management. Now, policy is very powerful. In this context here, one of the things I might choose to do is if I've got a set of tests that are deterministic in result, I can ultimately automate some of those things. So I can take the human interpretation element out of, say, the SonarQube results or the Black Duck results, right, by simply creating a policy around those things. And what will happen here is at runtime, when this gets kicked off, we'll look at that policy, we'll look at the data that we've collected about this run from one of those external tools, and ultimately decide whether or not this pipeline can continue, or if it needs to stop because someone needs to pay closer inspection to these things. And so this is another area where we're saying, let's reverse that paradigm of stop and look to let's analyze through automation and only stop if there's a problem. And again, you can manage that both velocity and risk at the same time. And so again, being able to do that here. The other thing that comes into play here is looking at the deployment and sort of where that's deployed. If I look back here at the pipeline that I was running, one of the things that I get asked as part of sort of this deployment strategy is, what account in what region do I want to deploy this thing to? Well, obviously, I want to make sure that each application it was within its lane, right? So I can put together a policy that says, look, this application can only be deployed here, right? And so ultimately we'll go ahead and perform that check as part of that policy check here, as part of the autopilot stack. So again, managing more risk, managing, sort of more compliance, being able to do that in an automated fashion. And then, the second to last bit that I want to talk about, given that I know we're running a little behind, is sort of the auditability of those things. And so, one of the areas that I think is important and is often overlooked with tools like Spinnaker is that idea of being able to conduct or have, sort of an audit trail of what happened and when it happened, right? This is true. This might not be specific to containerized workloads. It's really specific to all types of workloads, right? Whether you're monolithic, containerized, or microservices. And so I want to be able to tell what happened and when it happened. And I want to be able to, sort of add additional data points here. So if I want to be able to see things like what artifact was deployed, what cloud provider from a multi-cloud shop was it deployed to, what image was used, right? In this particular case, right? In our containerized piece. So if there was an image deployed there, what was it? And so ultimately, guys, what we're doing here is making sure that you have access to that data very quickly. And it's filling a really large gap in what is otherwise a really powerful underlying orchestration tool, that being Spinnaker. And I think you'll find the same thing with deployment solutions like Argo, Tecton, and if you're using Jenkins, let's say, you're using Groovy scripts or some other sort of glue code to do deployments. Getting to this information here can be very, very valuable, especially if you're in a regulated environment or you have, sort of audit as sort of a fact of life. So this is another piece that I think is really important. And then the last part that I want to talk about before we move over to any questions is around visibility, right? So I think that, one of the things that I find really interesting is, being able to understand, and you get some of this with Spinnaker, right? You get here's the cluster that this thing was deployed to, here's the load balancer that's in front of it. But one of the things that I think, a lot of our customers have asked us for is, hey, look, what's important to me is I want to know the state of affairs when this thing was deployed. So what was the status of the JIRA tickets when it was deployed? What were the SonarQube scans that got it approved? Who approved it, right? So something simple like that. So how did something get where it is today? What was the path to where it got to? And sort of how do I make sure that, I can ultimately audit that if I need to? So guys, I think what I want to do is I want to go back to the presentation here and ultimately because I know we're running a little tight on time, and make sure that we are leaving some time for questions. And so with that said, and actually before I go to that, I wanted to sort of put a small commercial in. OpsMx is a proud sponsor of DevOps World. We're going to be there, our virtual booth. All the information is down below there. Would really encourage you to come by and chat with us. I know I'll be there. Members of our management team will be there, but more importantly, senior members of our technical staff will be there. Our CTO will be there. The person that runs our engineering group will be there. And so a lot of people, if you have questions, if you want to talk, sort of, just general DevOps topics or concepts, come by. We'd be happy to sort of have that discussion. We'll also be doing some demos of our product, but really would encourage you to come by and visit us at DevOps World. It's usually pretty valuable, especially when in such a what's relatively a small community of people. I love to sort of meet people, talk to them about some of the issues that they face, and sort of brainstorm together on how we might help solve some of the problems that whether you're a customer of ours or not. We just like to make sure that we're helping people work through those issues. So let me stop there and turn it back over to Ash for any questions that may have made its way into the chat.
Thank you very much, Bob. That was a really informative presentation. Let me quickly run a quick poll because I think I've now got the polls working. So I'm going to, there you go. Let's launch. There you go. Continuous delivery and Spinnaker usage. Whilst you maybe take a stab at that, let me just quickly go ahead and say we'll be taking some questions. Please be sure to type your questions into the chat box if you haven't already done so. And hopefully it's time for a quick question or two, and then we'll hold it. So there you go. Hopefully you can do that one question. That would be awesome. And I'll also put the second up there if I can, if I've got enough time. Right, let's go to questions. So, question for you, Bob. Is Spinnaker better than Harness?
Yes. And let me tell you why. Let's get into it because I get this question a lot. And I know you might be thinking to yourself, hey, that's great. Clearly they come down along vendor lines. But guys, here's the thing that I think about when I look at a tool like Spinnaker versus Harness. And don't get me wrong, Harness is very well done. They've done a nice job there. They're a smart group of people. And they've put together a nice CD tool. However, The issue that I have with Harness, and again, I think that there are two disadvantages. One is the closed source nature of that tool, right? So you lose some of the leverage and benefit and innovation that goes into open source tools. Whereas with Spinnaker, you can fully leverage the innovation around that open source community. The other piece of this is the extensibility and flexibility of Spinnaker, especially when it comes to the OpsMx Intelligent Cloud. Here, with OpsMx Intelligent Cloud, you get all of the sort of hands-off from an administrative piece that you get with something like Harness. But what you're not sacrificing is the flexibility and the plug-in nature. So when we go ahead and develop custom job steps for our customers, when we go in and develop, custom stages for our customers, we don't have to wait for a new release. The way Spinnaker operates is you can actually plug those things into the existing. And so you don't become just an entry on a roadmap when you go out and buy a new tool. This is something that, we can ultimately help you implement in very, very short order, versus with something like Harness. Again, you wind up in that, hey, let me put this in our roadmap. Let me see how many people ask for it. Then let me make a decision as to whether or not we're going to do it. Here, it's very, very different because we can simply do it and not have to worry about, sort of waiting for the next release of Spinnaker in order for you to be able to take advantage of it.
So which is better for CD, Jenkins or Spinnaker?
Again, I think I'm going to say Spinnaker, and let me tell you why. I think that Jenkins is a world-class CI tool. I don't think, in my humble opinion, I don't think you can get much better in terms of its overall flexibility. But I think when it comes to doing CD, it's capable, and I think but I think that's like saying, I'm capable of pitching for the Mets, but nobody would let me do it, right? It's one of those situations where when you start looking at, sort of the scripting that needs to go into it and the maintenance of that scripting, and the limitations of that scripting. And then ultimately the last piece of this, especially those of you that are in a Kubernetes environment, but any sort of deployment sort of situation, those scripts tend to be fire and forget, right? There's no, you'll get, hey, the deployment script was run. With Spinnaker, you get a lot more in terms of not only just sort of integration of the entire CI/CD toolchain, but when you do that deployment, you actually can see the fact that the deployment happened. You can interact with the deployment without having to dive around in some of the Kubernetes commands or go out to that cloud provider and see whether or not it happened. So that's my take.
All right, that's fantastic, Bob. Thanks. I put up the second question. If folks have got a chance to put in their responses in, that would be fantastic. So I think we've answered all of the questions. I want to thank everybody for submitting them. Bob, is there anything else you want to cover before we wrap up?
Just one other thing, guys. I think from my perspective, I'm always happy to get emails or get questions from people. You might not be thinking of them right now, but please feel free to reach out to myself or reach out to OpsMx as an organization if we can be helpful. You'll also see us out there in the Spinnaker community, sort of helping folks out as well. Please, if you see someone, his name's Robin. If you see Robin out there, please say hi to him. But honestly, guys, let us know. We're happy to help as you start that sort of CD journey, or you start looking at automation tools that can help, sort of help you manage that three-legged stool. We'd be happy to share our experience, our knowledge, and sort of help you get there. So, but that's it for me.
Well, thanks very much. And certainly from my perspective, I'm always interested in understanding how people can simplify complexity, eliminate waste, and reduce friction across the continuous delivery lifecycle. So thank you very much, everybody. We much appreciate you joining us and look forward to seeing you hopefully at DevOps. Take care.
Thanks, guys.